only thing we were using the temp variable with was that while loop, so I'm going to drop that out of the diagram like that. And then the next line of code says tail equals pre. Well, tail and pre are already pointing to the same node, so tail is already equal to pre. So we'll remove that line of code, and then we'll say tail.next equals null. Well, tail.next is already equal to null, so we can remove that, and that just leaves us with this line of code where we decrement the length. So the length was 1, now we've decremented it, and now it's 0. So the length has been set to 0, but head and tail are still pointing to that node. And that's where the problem is. You shouldn't have a length of 0 and have head and tail pointing to a node. So we're going to say if the length is 0, and I'm going to bring back the rest of our code here because I want to point something out. Up here at the top, we said if length is equal to 0 here, and we're doing it again here. But there's a huge difference when we do it down here. This is happening after we have decremented the length. So we started out with a linked list with a length of 1, we decremented it, and it's now 0. The one up at the top is for a linked list where we started with 0. So if this is the case, we need to say head is equal to null and tail is equal to null, and that does this. And that takes care of that problem. The only thing left to do is to return that node. We do that by saying return temp. So that is our entire method, and we'll look at this in a moment in IntelliJ. And when we do, we're going to build a linked list with 2 items in it like this. And the reason we're doing this with 2 items in the linked list is we had 3 scenarios that we coded for. One was if we had 2 or more items in the linked list, so we want to make sure that code works and that we can remove that item. And then we want to make sure that it works when we have 1 item in the linked list, and then also if it doesn't have any items in the linked list. So let's flip over and take a look at this in IntelliJ. So there is our remove last method there that we just created. And then I'm going to come up here to this main tab and click on this. And this is where we create a linked list with nodes with the value of 1 and 2. And right here, I'm just going to print this out. And I'll run this. And you can see up here that we have a linked list with nodes with values of 1 and 2. So what I'm going to do is I'm going to come down here and replace this line that says print list with this code here. So let's walk through this. So each of these is identical, where it just says my linked list dot remove last, and we're printing out the results from that. And we're doing that 3 different times. One for when we have 2 items in the linked list, and then 1, and then 0. And I'm going to run this. And I'm going to zoom out here to show you this is what it looks like when it prints out a node. It's this whole line here. So to make sure that we're getting the correct nodes returned, I'm going to come down here and I'm going to add dot value to where this returned a node. But I'm not going to do that on this line here. And the reason is this line did not return a node. So if you look up here, this one returned null. So you cannot say null.value. That doesn't make any sense. You'll get an error. And I'm going to run this. And you can see that what is being returned is the node with the value of 2, then 1, then null. So I want to emphasize that you have to be careful adding the dot.
So in this video, I'm going So we've just seen that we can use what's called automated machine learning or auto ML to develop a model and just basically point it at the data. The data is properly labeled and it can go off and do its work. Now we want to still remain within the no code machine learning set, but we want to have some more control over it. We want to examine the data. We want to build the steps. And so the option for that is called the Azure ML Designer. So it is one of the ways that you can build a model within Microsoft machine learning. So this is considered a no-code approach, like the automated ML. So you're not actually writing any code, you're just building the model. For example, we're going to see this in a second. I'll do a live demo with the ML Designer just like I did with the Auto ML. But you can draw